I'm a cat person. So is the internet. And as it turns out, so is evolution itself. Across the long history of life, a surprising number of completely unrelated creatures have independently transformed into cats. Biologists call this convergent evolution. It means if a trait works, nature will repeat it, over and over again. Today, we are exploring the feline template, from a terrifying 800-kilogram monster to a bizarre cat-like reptile that lived 70 million years ago. What makes the cat body plan so perfect that evolution keeps reinventing it? And how did true cats actually come to be? True cat Felidae evolution. Cats belong to the family Felidae, which sits within the suborder Feliformia. This is one of the two great branches of the order Carnivora. The opposite branch, Caniformia, encompasses dogs, bears, badgers, raccoons, skunks, seals, sea lions, and more. The feliforms, besides cats, include hyenas, mongooses, civets, and several other lineages, plenty of them now extinct. The cat family likely diverged from its fellow feliforms roughly 33 million years ago, during the Oligocene epoch. The oldest unambiguous felid we've yet unearthed is a creature called Proilurus. Proilurus would have resembled today's viverids. Another cat-related feliform group, its remains turn up in Europe and possibly in Asia and North America too. It probably spent much of its life clambering through trees. This earliest chapter of felid history isn't terribly well understood because fossils from this interval are scarce. Yet molecular estimates from living species line up nicely with the sparse fossil evidence we have. In short, true cats first emerged between about 33 and 28.5 million years ago. Following Proilurus, the fossils of a creature named Pseudolurus begin appearing across Europe, Asia, and North America during the Miocene epoch. Once again, the finer points of feline evolution here remain hazy, and even the number of Pseudolurus species is uncertain. It's best understood as a complex grade of prehistoric felid with no firm definition and several names for the species groups it contains. Every later cat lineage seems to have descended from within this Pseudolurus grade, or something very much like it. Pseudolurus came in a range of sizes, from wildcat scale species up to puma scale ones. These animals were likely comfortable among the branches too, their slender frames and short legs marking them out as capable climbers. One lineage that branched off became the most celebrated of all prehistoric felids, these saber-toothed cats. Formerly, the Machaerodontines. One Pseudolurus species had notably elongated upper canines, which may mark the opening stage in the evolution of those lethal sabers. The earliest genuine saber-toothed cat we've found is Myomacharodus, known from fossils in Turkey and China dated to between 12.5 and 9.5 million years ago. Even so, the saber-toothed lineage probably arose earlier, splitting from the ancestors of all living cats around 20 million years ago. That lineage spawned several subgroups, the scimitar-toothed cats, such as Homotherium, the metallurines, such as Dinofelis, and the iconic Smilodontynes. Among them was Smilodon, which struck terror across prehistoric North America. The saber-toothed cats persisted until only 11,000 years ago, with Homotherium and Smilodon the final survivors. Beyond the saber-tooths, the other principal subfamilies within Felidae are Felinae and Pantherinae. The conical-toothed cats? Pantherinae covers lions, jaguars, leopards, tigers, snow leopards, and clouded leopards. Felinae takes in every other living cat. The two share a common ancestor from Asia and parted ways some 10.8 million years ago. Both subfamilies adapted to a vast array of environments across most continents, spreading from Asia in successive waves. By at least 9,500 years ago, humans were already domesticating cats. As shown by archaeological discoveries on Cyprus, these finds include a child interred alongside a cat, hinting at a powerful bond between the two species even then. Since cats weren't native to the island, Neolithic farmers must have been ferrying them over from elsewhere. Clearly, our affection for cats stretches back an awfully long way, and it's just as well we invented the internet to watch cat videos all day. Oddly enough, the so-called true cats, the felids, weren't the original cats at all. Several lineages predating the felids look astonishingly cat-like. One is the family Oxyaenidae. This group enters the fossil record around 59 million years ago, not long after the non-avian dinosaurs died out. They don't quite belong to the order Carnivora, so they aren't close kin to true cats and have an entirely separate origin. Nonetheless, some oxyenids do bear a superficial resemblance to cats. Oxyenids began as fairly small, weasel-like animals, but species like Patriofelis, dated to 50 to 46 million years ago, grew to roughly jaguar size and looked considerably more feline. Patriofelis had short legs and an elongated body, and appears to have been a terrestrial ambush hunter of large prey. It had broad snouts plus supple elbow joints and forelimbs well suited to wrestling quarry. Like all oxyenids, Patriofelis carried specialized shearing teeth toward the back of its jaws. The carnassials, these modified cheek teeth, work like scissors, with self-honing edges extremely effective at slicing flesh. Carnassials are a defining feature of many carnivorans. Watch your dog or cat chomp with the sides of their mouths, and that's them at work. These teeth evolved convergently among mammals several times, and arose independently in the oxyanids too. Another markedly feline oxyanid is Diego Eluris from California, a member of the subgroup Macaroidines. These oxyanids also had saber teeth, and they are in fact the oldest saber-toothed true mammals known. Paleonyctus from Europe and North America could also count as fairly cat-like. So could Sarcastodon, the largest oxyanid yet discovered, unearthed in Mongolia. This species may have weighed as much as 800 kilograms and stretched 3 meters long. Its enormous skull shows clear adaptations for crushing bone to reach the marrow, alongside teeth for shearing flesh. So this thing was effectively a bear-sized hyena-cat hybrid, magnificent, if slightly nightmarish. Related to the oxyanids are the hyenodonts, which also boast a few species arguably convergent with cats. Despite the name, hyenodonts aren't close relatives of hyenas and lack their bone-crunching specializations. They look more dog-like. They were formidable predators and endured far longer than the oxyanids, vanishing about 9 million years ago. The oxyanids, by contrast, died out around 40 million years ago. Although most don't look very feline, they all sport convergently evolved carnassials, one species. Simbakubwa is worth a mention. The name comes from the Swahili for big lion, and it lived roughly 22 million years ago in Kenya. Larger than a modern lion and a specialized hyper-carnivore, it may have targeted the colossal ancient elephants and rhinos. Its skull is still quite differently shaped from a cat's, but it's such a cool species I had to give it a mention. Another lineage of cat-like mammals arose before the so-called true cats, the family Nimravidae, sometimes dubbed the false saber-toothed cats. But since they lived before the saber-toothed cats, surely the false ones ought to be the real ones, which would make the real ones the false ones. I do love convergent evolution. It's not confusing in the slightest. Nimravidae first turns up about 40 million years ago, appearing in both North America and Eurasia. Many Nimravid species look remarkably feline in body and skull anatomy, leading the first paleontologists to file them under Felidae. Yet numerous subtle distinctions betray their separate origins. Various openings in the skull differ, and the inner ear is built quite differently. Nimravids walked not on their toes like true cats, but in a flatter-footed manner, a condition known as being plantigrade. Their long sabers are generally more conical and less flattened from side to side than those of the genuine saber-toothed cats. Nimravids ranged from house cat-sized species up to jaguar and lion-sized ones, such as Hoplophoneus in North America and Quercylurus from France. Most were ambush predators, likely preying on extinct hoofed mammals, including early horses and rhino relatives. The Nimravids went extinct in North America about 26 million years ago, producing what's known as the cat gap. That's a 7.5 million year absence of any cat-like predators on the continent, until the felids arrived from Eurasia roughly 18.5 million years ago. Another feliform lineage with a contested classification history is Barbarophelidae. These are more saber-toothed, cat-like mammals once regarded as a family distinct from the Nimravids, though some recent work hints they might actually be a subgroup within them. The Barbarophelids first surfaced about 17 million years ago, chiefly inhabiting Eurasia and Africa. One genus, the hulking Barbarophelus, crossed into North America around 13.6 million years ago and roamed there until about 7 million years ago. This animal wielded enormous sabers paired with large bony flanges on the lower jaw into which the canines would tuck. Comparable flanges also appear in some nimravids, such as Eusmelus. The reappearance of massive sabers in the feline build again point to hypercarnivorous ambush predators filling a cat niche. All while coexisting with the genuine saber-toothed cats, the Machaerodontines, throughout their existence. Whether the Barbarophelids are a distinct lineage or a Nimravid subfamily bears directly on our discussion of convergence. If separate, then highly cat-like saber-toothed forms evolved convergently within the feliforms on at least 3 occasions. But if they're a subfamily of Nimravids, as recent research leans toward, then only 2 convergent lineages are involved. Either way, the degree of convergence is pretty striking. That brings us to the next batch of remarkably cat-like mammals. And this time, the convergence is beyond dispute. There once existed a lineage of marsupial relatives that evolved features strikingly similar to those of cats. Marsupials are the pouched mammals, today including kangaroos, koalas, and possums. They split from the placental mammals more than 110 million years ago, making this a truly astonishing case of convergence. More precisely, the relatives in question are the sparassodonts, a lineage of marsupialiforms, not true marsupials, but very close, extinct cousins. Within them, it was the family Thylacosmilidae that produced some decidedly feline species. The thylacosmilids first appeared roughly 21 million years ago and lasted until about 3 million years ago in South America. Back then, the continent was a sparassodont stronghold, many having convergently evolved body plans like modern placental predators, including wolf and hyena-like species. Some sparassodonts may even have been omnivores. The best-known thylacosmilid is the jaguar-sized Thylacosmilus atrox, known from Argentina and living between roughly 7 and 3 million years ago. This predator would have been a true spectacle in the flesh. Thylacosmilus bore fearsome saber-toothed canines and an overall superficially feline build. It too had prominent mandibular flanges into which the canines slotted, another convergence with the Barbarophelids. Look closer, however, and many intriguing differences emerge. Its skull was distinctly unusual, with dome-shaped maxillary bones that lent its face an almost bulbous look. The canines of Thylacosmilus grew continuously throughout life, unlike those of felids. Moreover, those huge teeth were subtriangular in cross-section rather than blade-like. The rest of the dentition differed too heavily reduced incisors, rather small remaining teeth, and no sign of any carnassial-type teeth. As for the body, several convergences with true saber-toothed cats are evident, driven by similar pressures and hunting styles. The neck was long and heavily muscled, much like saber-toothed species such as Homotherium. Yet Thylacosmilus lacked retractable claws and had stockier but shorter limbs than a typical cat. Its forefeet were semi-digitigrade and its hind feet plantigrade, just like the Nimravids we met earlier. There's been plenty of debate over how Thylacosmilus actually behaved and hunted. It was probably an ambush predator, ill-suited to chasing prey across long distances. Its bones show it was well adapted to rearing up on its hind limbs, leading some to suggest it acted more like a bear than a cat. Older views cast it as a super saber-toothed predator, with teeth that dwarf those of many placentals. Recent research, however, highlighted many anatomical differences and suggested it may instead have been a specialized scavenger, perhaps using its long teeth to lever open carcasses and feed on the soft innards. Other researchers push back, finding support for it as an active hunter with neck muscles suited to driving the canines into prey. It might still have fed on internal organs, since wear marks on its teeth suggest mainly soft foods and an avoidance of bone. But Thylacos milis wasn't the only time the marsupialiforms converged on feline traits. In prehistoric Australia lived the so-called marsupial lion, a ferocious predator named Thylacoleo. Its most recent species, Thylacoleo carnifex, survived until about 40,000 years ago. It was the largest mammalian predator known to have evolved in Australia. Thylacoleo is a genuine marsupial, belonging to the suborder Vombatiformes. That makes it a close relative of living wombats and the koala, yet it independently evolved features echoing those of felids. One of the most striking examples lies in its teeth. Thylacoleo had enlarged, blade-like premolars on both jaws that operated exactly like the carnassials of cats, shearing chunks of flesh. So this marsupial, separated from placental carnivorans for over 100 million years, had independently evolved this specific dental weaponry. The rest of its dentition was rather unlike a cat's, however. The lower canines were absent and the upper ones tiny. Instead, the incisors had grown large and took over the role of feline canines. Paleontologists have calculated that Thylacoleo had the strongest bite force relative to body size of any mammal known. Another neat convergence is that Thylacoleo had retractable claws on its thumbs. Unlike cats, only the thumbs were so equipped, and they were also semi-opposable, capable of a wide range of motion. It seems this killer koala relative used them to seize prey before dispatching it with those deadly claws. It was likely a good climber too and may have pounced down from trees onto unsuspecting animals below. The marsupial's answer to a cat was thus a genuinely fearsome predator, with a fascinating blend of cat-like traits and unique anatomy. Next, let's take a brief detour out of deep time to consider some living mammals that have convergently evolved feline features. First, the fossa. This species, formerly Cryptoprocta ferox, is native to Madagascar and is another feliform. Genetic evidence shows its lineage. The Malagasy carnivorans all stem from a single colonization of the island 24 to 18 million years ago. This family, with 10 living species today, is most closely allied to the mongooses. A population of ancestrally mongoose-like mammals must have rafted across from mainland Africa and given rise to the Malagasy carnivorans, which millions of years on produced a cat-like species, the fossa. It's the largest carnivore in Madagascar, a splendid predator that evolved to hunt lemurs and other small to medium vertebrates. Skilled climbers, fossas dart along branches and trunks to chase down their primate prey. Overall, the fossa looks rather like a cougar, though sleeker, with a longer body and an elongated tail that aids balance in the canopy. Its skull is a touch longer than a cat's, yet it sports a fairly blunt, phalid-like snout. Remarkably, the fossa even has semi-retractable claws not sheathed as in cats, but extendable and then partly drawn back. The fossa, then, is another superb case of a lineage converging on cat-like anatomy where no native cat-like predators existed. Another set of living mammals worth a quick mention are the species of the marsupial genus Dasyurus, the quolls, sometimes called native cats. Though they don't look terribly feline at first glance, the quolls can be seen as the ecological counterparts of true cats among modern marsupials. Native to Australia and New Guinea, 6 species survive today, all effective climbers that hunt by night and shelter in burrows by day. The tiger quoll, at 1.25 meters including the tail, is the largest surviving native mammalian carnivore on mainland Australia apart from the dingo. It's their role as small to medium predators of other small vertebrates that has led some to regard them as cat equivalents. Sadly, the introduction of domestic cats and foxes to Australia has been devastating for quoll populations. As these invaders both prey on them and compete for the same food. So far we've stuck to mammals, but now I'm going to throw you a real curveball. What if I told you there was a croc that convergently evolved with cats? I promise I'm not making this up. There was a crocodiliform related to modern crocodiles, but not one of them, called Pachysuchus, whose skull and teeth are remarkably cat-like. Fittingly, the name Pachysuchus even derives from the Swahili word paka, meaning cat. This crocodiliform lived over 70 million years ago and was discovered in southwestern Tanzania. A small animal, about half a meter long. It was fully terrestrial. Its skull is short and broad, with a sturdy lower jaw and highly distinctive teeth differentiated into 3 types. That's far more like the mammalian condition than other crocs, which have uniformly shaped teeth along the jaws. At the front, Pachysuchus had caniniform teeth resembling true cat canines, then premolariform teeth, then molariform ones. So this reptile, descended from ancestors with rows of similar conical teeth, evolved specialized tooth groups for distinct functions, just like mammals. The molariform teeth even closely resemble the carnassials of cats and probably sheared flesh the same way. One paleontologist remarked that found in isolation, those teeth could have been mistaken for a mammal's. The low skull, slender body, and long limbs are further features making this astonishing croc seem like a reptilian cat. Curiously, Pachysuchus still retained heavy, bony armor plates on its tail, called osteoderms at odds with its agile body. Clearly a one-of-a-kind animal, and a fantastic creature to round off our tour of every time things evolved into cats. So here's the real question. If evolution keeps building the same cat over and over, across reptiles, marsupials, and mammals alike, then maybe the cat was never an accident at all. Maybe it's one of the answers nature arrives at whenever the conditions are right. A shape so effective that life keeps discovering it on different continents, in completely different families, separated by tens of millions of years. So what do you think, is the cat just one of many shapes life happens to fall into? Or is there something about this design that the universe seems to favor again and again? I'd love to hear where you land on that. So drop your thoughts down in the comments below. And if this video made you see these creatures a little differently, a like and a subscribe would mean a lot. Thank you so much for watching, and I'll see you in the next one.